Hello guys, my name is Kiki, and in this video I'm going to continue working on my Amazon return box. And this time I will work on a Belkin, let me check exactly, Powerhouse charge dock for Apple Watch and iPhone. So basically there is a plug for a wired connector for the iPhone, and there is a wireless pad for an iWatch. And there is an external power supply. And that's all. And I already checked that it does not charge at all. So let me plug it in and let me show you. So I plugged it in. I put in my iPhone. And as you can see, nothing is showing up. It's not charging at all. It has a pretty nice function. There is something like a potentiometer here, and you can set the height of this connector here, with this basically compensating the thickness of the different cases. So it's pretty cool idea. At first I had no idea what is this. It looked like a potentiometer here, but it's definitely not. It's a mechanical height change. So as a first thing, I will measure if we have 12 volts on the charger or on the power supply. I assume the middle point is the positive. And as you can see, here we have 12.1, 12.2 volts. My hand is shaking, so this is why it's not stable. 12.2 volts, so it's okay. So I will take it apart and let's see what we can find inside. I have no idea if I have to remove this, or I have to remove this rubber-like layer from the bottom, but I assume I have to remove it from here. Let's try to pry it off. Oh, yes. Oh. It's really strongly glued on, and here I can already see screws. Cool. Okay, this glue is pretty strong, so I need a relatively bigger screwdriver, a Phillips screw. Let's remove these 4 screws. Okay, and the bottom is a really huge metal plate. I think it's just to get it some weight to it. Are you kidding me? That's it. That's all. This is really crazy. It's a small little PCB. Yeah, but we should definitely have some kind of a charge controller, things like this, so maybe we have something on the other side. Let's remove the PCB. Okay, and now I'm able to remove it, and yes, here we have a few components, not a lot. It looks like here we have a fuse, and this will be the first thing I will check. And then we have some capacitors, and IC, most probably this is a charge controller IC. And here I can see another 6-pin IC. It's most probably like a voltage regulator, which is creating 5 volt or 3.3 volts to the charge controller IC. or anything like this. I have no idea exactly. So let's see if I can remove it further. I hope it will not jump into pieces. No. Okay, it came off in one piece. Okay, that's enough for me. So let me plug it in once again and let's measure if we have 12 volt. So to check if our connector is okay or not. And note, it's 0 volts. Maybe we have a short. Let's measure it in resistance mode, for example. Oh yeah, we have a 0 ohm short on the input pins. So I think I will go over to my microscope and let's take a closer look at the board if we can see any blown components or things like this. Okay, so let's see. It looks like we have quite a lot of deposit or something like this. I have no idea what is this on the PCB itself, but it's definitely not clean. So this is our plus pin, and then goes to the fuel. Then I measured already the fuse, it's okay. Then we have a few capacitors here, and goes into this MPSG48. I think this must be a charge controller IC. And then most probably it goes from here to several additional points, but let's see at first if we can find any blown components. And that's all basically. That's the entire PCB. I cannot see. Both ICs looks okay. Also the capacitors look absolutely okay to me. So what I'm going to do, because here we have a rather simple PCB and we have a nice short, almost that short. We use something like 1 or 2 volts. 1 volt at first with my power supply. I think I could use even higher voltage like 3, for example, because yeah, the charging will work from 3 volt or from 5 volt anyway. So, but yeah, let's just ramp up the voltage nice and slowly. First I will start with 1 volt and 2 amps, for example, and let's see. And we use a nice trick. I will grab my compressed air spray. So it's just a standard compressed air spray. If you shake it upside down and you spray it over the board, then you can basically freeze the entire PCB. And then if I apply power with my power supply, then most probably the component which is on short will heat up the fastest, and basically the freezing will melt, or the ice will melt on that component, the first one. At least I'm hoping. So this way basically all the components are on the screen. Let's spray it over. And you can see that it's freezing basically in seconds. It's pretty cool. I really like this. And now I will apply power to the board 1, 2 and 3. And I think this middle capacitor was the fastest one. Let's do it once again. So look at this capacitor in the middle here. In 3 seconds. 1, 2 and 3. Yeah, and definitely this capacitor is melting the ice on it the fastest. So maybe we found the culprit. I will at first just nice and slowly let the board to heat up, or maybe with the hot air station, but from low temperature I will heat it up slowly. I do not want to shock the board immediately. And then unfortunately I already killed my hot tweezers tip, so I cannot use that. I think I will add some solder to the two sides of this resistor, and then with hot air I try to remove it. Okay, so now I dried up the PCB. I will apply a little bit of flux and then add a little bit of solder with my soldering iron. Okay, and now with the help of hot air I will remove the capacitor. Okay, now I will switch back to the camera and let's measure again. I can also measure in continuity mode. And we have an open loop, OL. So it means that our short is gone. I can also measure directly on this capacitor. And yes, maybe we solved the problem so easily. It would be cool. What I'm going to do, I will most probably pull one of the other capacitor. Either pull one of the other capacitor to replace to know what is the capacitance value of these capacitors one by one. I mean, I only have to pull one of them and measure it. And then I hope I can find one and I can put back later on. But at first, let's see if it works now. Okay, so I plugged it in. Let's measure no voltage again. And we have 12.2 volts on the pins. So it's definitely not shorted anymore. And now let's connect to my phone. And yes, it's charging. It's charging. Cool. I'm really happy about this. It turned out again. It was really a little fault. It was easy to find. So let's pull another capacitor. And then I will measure the capacitance of that capacitor. And then later on I can replace it. I hope I have a similar value. If it's higher, it's not a problem, but we should have at least the same voltage reading. I mean, we have a 12 volt input, so we would need at least a 16 volt capacitor here. Let's go back under the microscope. And let's measure the capacitance of this capacitor. I think it's something like 10 to 20 microfarad maybe. So as you can see, it's a 22 microfarad capacitor. And the size is maybe 0.805 or something like this. 0.603 maybe. I have to check if I have something similar. Okay guys, so I could not find a capacitor with the same capacitance. I only found smaller. I mean 10 microfarad. So I will order a similar capacitor like this, 22 microfarad in this size, and then I will replace this capacitor. And now I will finish my video here, because our problem is solved. Basically, this is already the boring stuff, cleaning up the PCB and replacing that single capacitor. So I hope you enjoyed this video. Hopefully it was helpful. If yes, please don't forget to like the video, subscribe to my channel, and I hope I see you next time. Bye.